Okay, so I'm going to be talking about standard deviation, which is a way to get error when there is no accepted value for the number you're trying to do error on. And then I'm going to show an example. So standard deviation, as I already said, is a way to get error. It is usually written out like this, where this is the average of all the data points you have, and this is the standard amount that the other data points deviated from that average. That's why it's called standard deviation. It's a real shocker. So the formula for standard deviation looks like this. The S stands for standard deviation because this starts with an S and it's easy. And then this is the rest of it. The N and this thing are both new. The sigma and this little xi are not. So what these things mean, N is your number of samples or measurements, whatever you want to call it. That's pretty simple. Xi, in case you forgot, I think it's in another equation, but it stands for like each individual data point you have. And this symbol, this X, this is not a vector hat, it is just a straight line, and it stands for the mean of all your data points. Yeah, and the sigma has been covered already in another equation. These little things on top and on bottom are pretty standard. I actually don't know what they stand for, but they don't matter very much right now. Standard deviation is also generally used for like very large sets of data where you have a lot of numbers to be comparing. But for this example, I'm just going to be doing a small set because it's easier. Okay, so for AP Lab 2, we had to determine B and N on a coffee filter, where B is the drag coefficient and N is the exponent. And we had to perform error on N. So what I'm going to do is I'm going to do a little example where we're just going to pretend, we're going to fantasize for a little bit that we don't know the accepted value of N, but we still have to do error on it. So, generally, there's another form of standard deviation which we probably would have used for this lab, which is for smaller data sets, and it tells you not only like how far your data points on average deviated from the average, but it also factors in how far your original average is from what it should be. But that's really complicated, and to be quite frank, I have no idea what the formula is. So we're just gonna do normal standard deviation. So we're gonna I'm gonna make up just like a set of numbers for N that you might have gotten from this experiment that we did. Yeah, if I had my lab notebook, I would take the real values I got, but it's currently being graded. So we're just gonna go with these. So let's say these are all your different values of N you got for this experiment. Each one will correspond to this little thing at one point, you know, this xi, which is each individual data point. And then this, the average of all these, or the mean, comes out to 10.01 divided by 5, which equals 2.002. Capital N from the equation will come out to be 5, in case you couldn't tell. Okay, so here's our formula again, and a lot smaller. You'll notice I'm disregarding those things above and below sigma because we don't care about them. And what you're going to want to do first is this part. So let's put in the first data point, just for simplicity's sake. So there we go. This is called math. It's very simple. We've been doing this type of math. Well, okay, not the squaring, but we've been doing this type of math for a while now. And this number comes out to 0.009604 once you're all done with it. You're then going to do this section again, but you are going to put in another data point that you have. So we'll go with the second one for simplicity's sake. And that will come out to another number, shockingly enough. 3504. You'll notice these are always positive because they're always squared. That makes things just easier. So you do this with every data point you have, basically, inserting them right here. Okay, so I went ahead and did the rest for you, so it's gonna be this and then all of these. For the record, if you're using Excel or Google Sheets for a lab and you want to do standard deviation, there is a command you can plug in the same way you plug in formulas, except you don't have to plug in all of these symbols. Anyway, so what you're going to do now is you're going to do the whole sigma thing again. You're just going to add all of these up. So that will take more time. So I saved you that time again. This is what they all come out to when you add them up. And you're gonna plug that into your equation again. I'm gonna get a new sheet of paper because this is kind of getting messed up. But what it looks like now is S equals 5 minus 1 because 5 is again, your number of measurements. And then you're going to put that number we just got in here because this number equals sigma x minus x squared, as we just did. And now, basically, it's just math. This part is very easy, and frankly, if you can't do it, I'm mildly concerned. And S will come out to about 2.03 or so. So now basically what you just do, you take your average, which was 2.002, and plus or minus 0.203, and that's your standard deviation error. Basically, that is pretty much it. It's a very simple way of doing it. I mean, it does have its flaws, obviously. As we know when we did the experiment, n actually equals 2. So the average was actually closer than this whole standard deviation thing. But, you know, you have to admit it's pretty close and pretty accurate. When people do standard deviation, they will often also do like 2s, you know, so just double the standard deviation, so like 2.02 plus 0.406, because it's plus or minus 0.406, because it's more accurate, they feel like. So when you see like numbers and you're looking through something that's like, you know, we had a value of 14.7 plus or minus 0.0002, and they're using standard deviation. That's a pretty good number. And yeah, that's basically it. Standard deviation is very easy, even though the formula looks kind of complicated at first. If you want to use it, go ahead. It does work only for values that do not change, obviously. So like you cannot do it on the coefficient of restitution of a bouncing ball. That does not work, as I found out. But you could do it on the exponent n, for example. Or, heck, you could have done it on b, coefficient of the drag coefficient of a coffee filter for lab 2 if you had so wished. Yeah. That's all. Thing are both new. The sigma and this little xi are not. So what these things mean, n is your, and this is the standard amount that the other data points deviated from that average. That's why it's called standard deviation. It's a real shocker. So the formula for standard deviation looks like this. The S stands for standard deviation because this starts with an S and it's easy. And then this is the rest of it. The N and this, and then I'm going to show an example. So standard deviation, as I already said, is a way to get error. It is usually written out like this, where this is the average of all the data points you have. Okay, so I'm going to be talking about standard deviation, which is a way to get error when there is no accepted value for the number you're trying to do error on.